6.5, solving radical equations. In this section, it's pretty easy. I think you'll like it. The one thing is I can strongly suggest that you check always for extraneous solutions, because sometimes some of the problems will come up with answers. None of them will work. Sometimes one will work. Sometimes both will work. But most of the time, you're going to have to check. And I'm going to show you a way mathematically to check it and by the calculator. All right, so let's get started. All right, radical equations are equations that contain a radical expression. If it's a square root equation, it'll have an index of 2. Otherwise, it's just a plain old ordinary radical equation. You must check your solutions to see if it satisfies the equation, because if the solutions do not work, they're called extraneous solutions. Because we are squaring both sides of the equation when we're working these out, you do not need a plus minus symbol. We use that only when we take the square root of both sides. So there's a difference. What we're going to be doing today is squaring. Okay, so you don't have to have that plus minus in if we are squaring. All right, so for example, you're going to have this problem like this. 3 plus the square root of 2x minus 3, that's all under the radical, and that equals 8. You have worked these problems before. Remember, the whole key to this is to isolate the radical sign and then go from there. So if we need to isolate the radical sign in solving this, we need to move this 3. And if we're going to do that, we're going to use the same techniques we've always done when we're solving equations. We're going to do the opposite of what it is. So if this is positive 3, we're going to subtract 3 from both sides. This will go away. Now we have the square root of 2x minus 3 equals, and 8 minus 3 is 5. All right, now in order to get rid of the square root, then we must square both sides. And we did this when we were doing complex numbers, so this should not be anything new to you. Whoops, sorry. I did not want to do that. So I'm going to square this side, and if I do it to one side, I must do it to the other. So then in order to get rid of this, what happens is this little understood 2 in the index and this 2 cancel each other out, which means they cancel out this whole sign. So you just are left with 2x minus 3 equals, and 5 squared is 25. Now you have a very simple algebra problem. Adding 3 again. And I'm going to move this up here. So you'll have 2x equals 28. Equals 28. And then you're going to end up with x being 14. Now again, you must check your work on these, because sometimes this answer will not be true. So we're going to put it into the original equation, 3 plus the square root of 2, and instead of the x, I'm going to plug in a 14. Now you'll notice I'm using parentheses, and I stress very strongly that you do the same, because of the problems that you've seen when we were doing the quadratic formula. All right, now remember, if you're using a TI-83, it'll give you a parenthesis right here automatically under your radical symbol. You need to close it off, okay? So it's really got one right here. So you have 2 parentheses facing this way and 2 this way, so it won't give you an error. So what's 2 times 14, which is 28? 28 minus 3 is 25, so that's going to be the square root of 25. 3 plus the square root of 25, does that equal 8? Well, the square root of 25 is 5. Does that equal 8? Yes, 8 equals 8. So yes, 14 is a solution. Okay? That is what you're going to need to do every time, because some of these are not just going to have one answer. Some will have more than one, because you may have to factor out stuff. All right? Let's try another one. All right, so this one is the cube root of 2x plus 1 equals 3. So we're going to handle it the same way. Isolate the radical. Well, that's all that's over here, so we can go ahead and decide how do we get rid of the radical in this case. Well, it's the cube root, so we're going to have to cube whatever we want to get rid of. So I'm going to write the cube root of 2x plus 1. I'm going to cube that. And I'm also going to cube whatever is on the other side of the equation. So that means that this cube right here, the radical, and that will all go away. So you're just left with 2x plus 1 equals, and then 3 to the third power is 27. Subtract 1, and you have 2x equals 26. So x is 13. We must check our answer. So I'm going to take the cube root of 2 times 13 plus 1. Does that equal 3? Well, 2 times 13 is 26. 26 plus 1 is 27. The cube root of 27 equals 3. Yes, that is true. 3 equals 3. So x equals 13 is definitely an answer. Okay? All right. Now, this one is not in radical form, but you can treat it similarly, but you're going to get rid of your exponents first. So what you're going to want to do, you still have to get rid of this 3 first. You want to isolate the parentheses or whatever the grouping symbol is that you have. Okay, so you're going to want to divide by 3. So this is going to be x, whoops, I'm writing x plus 1 quantity raised to the 2/3, we still haven't done anything with that, equals 12 divided by 3 to get rid of this 3. So that's going to be 4. Okay? Then you're going to try to find something that'll make this equal to 1. Remember, that's the thing, trying to make fractions equal to 1. So if I flip this and made this, let's change color, 3 over 2, the reciprocal would make 6 over 6, which is 1. So that's what I'm going to do. If I'm going to do this, I'm going to multiply this side by 3 over 2, and then that means I have to multiply that side and raise it to the same power. Okay, so I'm going to end up with multiplying this by 3 squared right there, which will make that just 1. So this will be x plus 1 over here, and I'm going to raise this 4 to the 3 halves power. Okay, so when you do 4 to the 3 halves power, that's the same thing, if you want to think about it, the same thing at, whoops, not that. No, hold on. There you go, erase that. That is the same thing as the square root of 4 to the 3rd power. 4 to the 3rd power, 4 times 4 times 4, which is 64. So this is the square root of 64, which is 8. So this is now going to be 8. So that's going to be x equals 7. And you subtract 1. So x equals 7. Alright, so then let's check and see if that's true. So I'm going to plug in 3, 7 plus 1 raised to the 2/3. Does that equal 12? Alright, so 7 plus 1 is 8 raised to the 2/3 times 3. Does that equal 12? Now remember, you have to do your exponents first, so you do 8 and then raise 2, and then you have to use the parentheses for the 2/3, okay? Otherwise it won't do it right. Then you times that by 3, and that gives us 12. So yes, this is 12 equals 12, which is true. Okay? Now let me show you what I'm talking about on this part right here with the calculator. Okay? Let's go back. Turn it back on. Okay, you have to go like this when you're doing this 8 to the 2/3. You have to go 8, raised to, and then parenthesis 2 divided by 3 parenthesis. Otherwise, it will mess up your answer because it does order of operations. That gives you 4. 4 times 3 gives you 12. Okay? Now, the nice thing about these radical equations is you can check your answers very, very easily with your calculator. Okay, for instance, let's take this problem up here. If I wanted to do the cube root of 2x plus 1, I would go math, and then the number 4 option, the cube root of 2x plus 1, and close it off. And then, where it says equal 3, you go down to y2, and you put a 3. Right? So you do one half of the equation in y1, and the other half of the equation, no matter what it is, in y2, and then you graph it. Alright, let me zoom in a little bit. I think it'll be easier for you to see. Maybe not. Let's see, zoom. Let's try this and see if it'll show you better. Nope. Alright, let me go back to the regular window. What I want to show you is what's happened over here. So I'm going to go second trace, and I'm going to hit value. I'm going to know 0. What I want is the intersection. Let's do intersection. Okay, move your little mouse guy. On this side, and move your little mouse guy. And hit enter, enter. And you're going to see x is 13. It intersects right there, and it's x is 13. There's only one intersection, and it is at 13. If you go to the table, and you look at x is 13, notice that it has the same y values for both equations. So you can easily see what the answer is, really, without doing the work, but you need to be able to know how to do this. It's very simple. We've already done this in class, so I'm expecting you to show me some work. But you can check your answers in your calculator. You can see if there's one solution or no solutions or two solutions, and you can tell me exactly what they are with your calculator. All right, so let's go and look at, clear this out. Let's look at the very first problem. Move this back. Go back. Whoops, not that far. There. This problem right here. Alright, I want to put this in my calculator. Alright, I'm going to put everything on the left-hand side in the calculator just like you see it. 3 plus the square root 2x minus 3, close it off. That's on one equation, and then the very next line is going to be an 8. That's all that's over on that side. I'm going to graph it. Okay, and we're looking for the intersections. The second trace, 5, and let me move him over closer. and hit enter. And then I want to be on the other side of the line. Now, since we've already done this problem, we know where about it needs to be. And I'm going to hit enter and enter again. And again, it says x is 14, which is what we got right here. And you can see it only intersects in one place, so there's only one solution. Okay, so x is 14 is correct. All right, so you can use your calculator to do that with all of these. So feel free to do that and get used to checking your solutions. Anytime you have equations, whether it has a square root in it or whatever, it could have a simple 2x plus 3 equals 10. If you couldn't do your math for some reason, you can always put in your calculator and find your answer this way, just like any others. It's absolute values you can do this way. Rational equations, which we'll have in a few weeks, you can do it this way. But anything with any equal sign, you can split it up and graph it and see where it intersects. That's the whole point of all this. All right, so I think that's all we have on this video. So if you have any questions, just come see me in class.